Alright, lesson 2 on segment relationships. Our learning goal. At the end of this lesson, you should be able to describe, define, and sketch the following as well as problem solve with justifications. So make sure you have your vocab stuff out. Segment length, segment addition postulate, midpoint on a numbered line, congruent segments, regular midpoint in the coordinate plane, segment bisector, and then justifying as we go. So let's get started. Talking about distance between 2 points on a line. When we're given just a number line, all we're going to do is take the absolute value of those two numbers subtracted. Remember, absolute value is the positive version of the distance. So, in example 1, I got segment. Remember, no arrows mean segments. PR. I have P is at -5, R is at 4. So all I'm going to do is take my absolute value, -5 minus 4. I know -5 minus 4 is absolute value of -9. The absolute value of -9 is 9. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, it works out. If I find the length of QT, Q is at -2, T is at 8. Let's go the other way this time. Absolute value of 8 minus a -2. Well, I know 8 minus -2. Minus a negative is like a plus. 8 plus 2 is 10. 10 is already positive. And then lastly, QS. Q is at -2, S is at 5. So I'm going to go 5 minus -2. And I know that 5 plus 2 is 7. So, if I use that on my exercises 4 through 6, it says on 4, if GH is 31, so I'm going to fill that in. It says GH is 31. And then it says HI is 10. So HI is 10. And we want to know how big GI is. Well, GI is just the whole thing. So if I have a chunk that's 31 and a chunk that's 10, I just have to add these two together. So 31 plus 10 gives me 41. Next problem looks a tinge different. It says GH is 45. And then it says GI. So the whole thing from G to I is 67. And I need to find HI. That's what I'm looking for. Well, if the whole thing is 67 and I know there's a chunk that's 45, all I have to do is subtract. So if I take 67 minus 45, what I'm left with should be what HI is. And that number is 22. Right outside the box, otherwise you're not going to be able to see it. Alright, so that is our briefly, our segment addition postulate. We're going to get into it a little bit more here. So it says if 3 points, A, B, and C are collinear, remember that means on the same line, and B is between A and C, then we can add our segments together to make a big one. So AB plus BC equals the whole thing AC. So it says, make a sketch and write the segment addition postulate for the points desired, then use the information given to find the missing measure. So it says A is between D and B. So I'm going to draw a line. I'm going to put D on one end, B on another, and then I'm going to put A in between them. The info below tells me DA is 4. It says is 5, and it wants to know how big dB is. So the whole thing. So I know I'm going to add them together. 4 plus 5 equals 9. Same thing with the next one. R is between B and Y. So I'm going to draw a line with endpoints B and Y, and I'm going to put R in between them. This time tells me BR is 5, BY is 12, BY being the whole thing is 12, and it wants me to figure out RY, this little chunk. So the whole thing's 12, I know a chunk is 5, so RY, the point I'm looking for, is going to be 12 minus 5, which gives me 7. Kind of looks like Y. Alright. If you need to go over those, pause, rewind, whatever works for you. Alright, so it says GH is 7Y plus 3. I'm going to label that. GH 7Y plus 3. HI is 3Y minus 5. And GI, the whole thing, is 9Y plus 7. Alright, so the first thing we're going to do is find the value of Y. But you'll notice we have this little thing that says justify each step. So we will do that. The little postulate we're using is called segment addition postulate. Now we're just kind of turning it into algebra, just a little bit more advanced, one step. So what I know is that the two smaller segments add up to be the bigger segment. So what I know is that GH plus HI equals that big segment GI. So that's kind of our statement. Then over to the right, we're going to justify, and that's called the segment addition postulate. I kind of abbreviate segment addition postulate. Well, now I know what GH, HI, and GI are, so I'm going to plug them in. So GH I know is 7Y plus 3. HI, I'm going to put those in parentheses, is 3Y minus 5. And GI, the whole thing, is 9Y plus 7. That step is called substitution. All we did is plug in what we know. Substitution. So now we're just going to simplify. Combine like terms. I got 7Y plus 3Y. I know that's 10Y. And then I got 3 plus a negative 5. 3 plus a negative 5 gives me minus 2. And then leave what you have on the right side, 9Y plus 7. In that step, we just simplified. Alright, now I'm going to do some algebra. I'm going to solve. I'm going to subtract 9Y. So if I subtract 9Y from each side, I'm left with Y minus 2 on the left and 7 on the right. All I did there was subtraction. And then I need to get that negative 2 over, so I'm going to add. So Y equals 9, and that's by addition, or add, whatever you want to write. Alright, so we found Y, and we justified each step. Now, what we got to do, part B, says to find GH, HI, and GI. Well, I know what they are in terms of Y. Now I just have to plug them in. So GH, that green right here. So GH is 7Y. Well, instead of Y, I'm going to write 9 plus 3. So I got 7 times 9 plus 3, and that gives me 66. So GH is 66. Next, I got HI. HI is 3 times Y, which is 9, minus 5. So I plug in my calculator, 3 times 9 minus 5, and I get out 22. And then lastly, we got the big thing, GI. GI we said was 9y, so y I'm gonna write 9. Plus 7, I know 9 times 9 is 81. Add 7 to that and I get 88. The whole thing is 88. What I like to do is check to make sure, is that true? Do the smaller segments add up to the bigger segments? So does 66 plus 22 equal 88? And yes, it does.